Hey guys, welcome back to Swat Studs. Today we are going to look at the second part of Lego head making tutorial, and that would be the texturing and look development of the Legos. And in this video, I'm going to explain how I managed to create 20 different texture variations on the instance of Legos with a single shader using the aiswitch shader in Arnold. So we will be more focused about how we can create that much amount of variations using the aiswitch shader. After that, I'm going to explain some shading techniques on creating subsurface scattering, and then we'll look at a simple lighting setup with an HDRI to see how the texture and shading is looking. So that's all the things we are going to look at in this tutorial today. So here I have a Maya scene, which is what we have left in the first tutorial. So on the last part, we had an issue with the transform node. When we were creating the initial state wasn't working. It was not touching the grounds when we are putting the initial state and changing the time slider back to frame 1. It was actually a bit higher from the ground because of this transform node, which we have put the values. When I checked on that file, putting back the transform value to 0 worked, and it was coming like this. But when I reopened the file and did it today, it kind of magically worked without changing the transform values. So I guess that was a glitch or bug in Maya Mesh. I'm not sure. So the first thing I am going to do here is we are going to set up a camera, and then I'm going to create a skydome light. So first we are going to set up a lighting, which is going to be the base light rig for our shading, or it's just to see that how the textures are coming when we are rendering. So I'm going to add an HDRI on the color. So selecting a file node and adding an HDRI. Okay, I'm going to use this Lidenhold Market 4K EXR HDRI. All these HDRIs are downloaded from polyhaven.com. So there are like huge collection of HDRIs which you can download for free. So in the first part, I have already talked about setting up camera, setting up resolution, and setting up the focal length, why we are setting up that focal length, and what differences does that make. So if you haven't watched that tutorial, I'll put the link in the description. So make sure you watch that first before watching this video. If you are only interested in shading, then do watch it, please. So I am going to do a render now and see what we are getting in render. So here, since I have, let me lock this camera so I don't accidentally move the frame from that. So now you can see I have enabled 3D manipulation. That's why camera angle is changing. So now we have assigned a symbol Lambert with a texture, and that is which is getting visible here. Now what I'm going to do here is that I'm going to create an AI standard surface shader. So I'm going to create an AI standard surface shader, and I'm going to connect an aiswitch shader to the color of the AI standard surface, and I'm going to connect the head 1 PNG into the input 0 of the AI standard surface, and I'm going to connect the AI standard surface to the Lego heads. So now you can see you got some speculars. In the Lambert, there was no specular, it's just pure diffuse. So now I think I can go a bit more in resolution. So on the final render, I used a 4K resolution, but for the sake of this tutorial, I'm just using Full HD. Maybe I'll go a bit lower than that in the test resolution, maybe 75, so that the render is faster. And I have already added a denoise optics, which is really good to see the outputs faster with denoising, and the denoiser optics works much better than any other denoising in the Arnold with the IPR interactive rendering. So now we have by default a lighting setup which works really good. I have used this light on one of my renders and it looks really good, but for the shading I think this will be a good point to start. Now you can see that there are some areas which we are seeing a bit of gap. Let me try to change my frame a bit to remove that. Okay. And now let me put the camera locked. So here on the AI switch, you can see that there are number of inputs. So you can connect any amount of textures into these all inputs one by one, and you can use the index number to tell the shader to which input should go into the color or whatever attributes to which the AI switch is connected. So here I have only connected one texture, so it is in the input 0. That's why we have put the index number to 0. If I put index number 1, the texture goes black because nothing is connected in the input 1. If I connected the head 01 into the input 1 as well, then we get the texture in the input 1. So I am going to quickly duplicate and renumber it to other textures so that you can see what are the other textures I have. Since this is going to take some time, I'm going to fast forward the video a bit. It's just that I'm going to duplicate the head textures and then I'm going to rename the textures. It's just by renaming, I'm just loading the all current textures which I have already set up on my folder. So I'm just changing the name so that it will read that particular images. So let me quickly finish this and we'll go to the next process. So I have connected all the textures onto the switch shader, and if we render now and I change the index number, you can see each of them has its own unique expressions like this. So you can add up to 20 textures onto a single AI switch. If you need more, you will have to add another AI switch and maybe connect the first AI switch to the input 0 or something. We are not going into that kind of complicated shader setup now. We are trying to keep it as simple as possible. So there is no complication in this one. I'm just connected all the texture nodes into the inputs, and now you can see that for the texture variations we need to change the index number. So what if I can create something that will change the index number on each instance of the Lego heads, so that each Lego heads will have its own random index numbers and it will take the random textures according to the index number. So that's how we are going to create the variation on the textures here. To create that per object index number variation, I am going to use a node called AI color jitter. So AI color jitter uses procedural per object type to create variation on texture's brightness or hue or saturation, etc. So here we have connected an input color as white, and if we add gain min and max, let's say up to 20, and change the type to object, what it will do here is that it will assign a variation of brightness between 0 and 20. So we'll get something like, I'll show you now. I'm just adding color here, and you will get a different brightness values here. If I change the exposure or turn down the exposure a bit, you can see how much variation of brightness you are getting. So if I put the values here, you can see that's the pixel value of 20 or 21. This one is around 4.6 or 7. This one is around 7. This one is 15. So you are getting random values per object or per instance. So let me connect the switch back to the color, and from here I am going to connect the out color red channel. Since index is a scalar value, we can only add a single channel to the index value. So I'm just selecting the red channel, and I'm going to connect that into the index. Now let's see if we are getting a difference. So you can see we are getting a really good variation of Lego heads, but if I am seeing here, the problem I see is that most of the adjacent Lego heads have similar kind of textures. Here you can see similar values. So for that, you can adjust the variations a bit. You can even go to -1 or -10 value. So we'll get a different variations of textures. So the reason I am going into minus values is that I'll show you with a simple example here. So let me hide this instance quickly, and I'm going to create some balls here. And I'm going to connect a standard surface onto the balls. And I'm going to connect a switch shader into the color. And for the switch shader, I'm going to create a color correct. And I'm going to create random values, color values here. Let me just add the default RGB and CMYK colors. It's just for demonstration so that you can understand it better. So we have 6 colors and we have 9 of the balls. So I'm going to connect all of this into each inputs. And I'm going to connect an color jitter. So one thing you have to notice is that when you have connected the input textures, whatever number of inputs you have connected, you will have to create the gain max up to that number, because if you have connected up to 5 and in the color jitter, if you put 6 or maybe 10 value, there is no textures added into the input of that particular value. If it read a value of 10 from the color jitter, it will try to connect the color node as input 10, and since input 10 doesn't have any textures loaded, it will render black. So I'll show you that example now. So I'm going to connect and add gain max to 10 and see the renders. I forgot to change the user type, and now I'm going to, so you can see I've put the gain max to 10 and there are some balls which are rendered as black. Also, you can notice not all the colors are present here now, and some of the balls or spheres have same color. So even if you put the proper values, like let's say 6 here, you can't be sure that all the colors which you have added onto the switch shader will be rendered on all the objects. Since I have connected 20 textures, I won't be sure that I'm rendering all the 20 textures on that scene. So in order to get maximum number of shaders, I have to tweak the color jitter value a bit. So on gain max, we are still getting a black one. So if you put, let's say 5.9, then we are okay. Like if we have put any decimal values, it will round the value into integer number. So in switch, if you get, let's say, value of 4.8, it will round the value to be an integer, which is 4. And before we have put a value of 6, which is an integer, and we don't have any texture added into the input 6. Any object which reads its input value as 6, the switch shader is gonna render it black. So that is what was happening here. And if you have noticed, I did add a red color, which is not present here. Even blue is not present here. So let's see if we can bring all the colors here. So that's the reason I was going into values of minus, so that we are getting all the colors. So even if you go to minus, it won't read that value as a negative number. It will somehow convert the numbers into a positive value. So in negative value, there is no limit to how much numbers you can go backwards. Let's say if you go minus 10, it's still gonna render all the colors without any black. So if I go to up to minus 20, so I think probability of red color is increasing when we are going into the minus values more. So let us not go into that much minus values here, and let me see if I can get a lot more variations here. So that is almost all the colors, but still not enough. So I'll see. So if you want another variation of colors or another color randomization on the balls, you can use the seed attribute. So if I change the seed value, the colors will change accordingly. You see. So here we are seeing black value. So I'm not sure why. Yeah. So I guess 5.8 was reading it as a 6 maybe. So if we have put an input value till input 5, let's not go above a value of 5. So I hope you get the idea why we are going into the negative values and what is actually happening when we are connecting textures into the AI switch shader and controlling per object color or texture with the color jitter node. So if you are changing the hue or saturation, it doesn't change the luminance value of that particular color. That is why we are not using hue min and max here. We can only use gain min and max to create these color variations. So let me bring my Legos back. Let me hide this for now and let me unhide the Lego heads. So here, from what we have just seen, all I can do here to see some variation is try to change the numbers a bit and see if that is giving me enough variations on the textures. And let's not change the gain max value. I will try to see if I'm getting a good amount of variation here. This guy asks a lot of attention because of that cool glass with a blue color. It's getting noticed very much, so I don't want this guy to be noticeable. Let's try another numbers. And if you are not getting enough variation with changing the gain min and max, you can use the seed values just to see if you're getting enough variations. So still not getting enough. So this is what I always tell you. You try to tweak the shaders as much as you can so that you get the output that you are satisfied with. So I'll keep on doing until I get a image which feels to have more variation on the texture heads. So I guess this one looks fine for this tutorial. I hope you got the point I was trying to make. So the next thing would be to add shader to the floor. So I'll just add a yellow color onto the floor so that you see it doesn't feel like a floor, it feels like another Lego heads beneath all these Lego heads. So this is how you create variation on the textures with the AI color jitter and AI switch shader. You can try to be creative and create different kind of objects with color variations with the AI switch. Sometimes I use it to create variation on the trees. If I'm using a single instance trees to create an entire forest, I'll need variation on these branches and leaves, right? So I can use this color jitter to create some kind of hue and saturation variation on leaves colors so that it feels more natural. Now let's add some subsurface scattering here. Before that, I'm going to go to the sampling and see if I have put enough subsurface scattering samples here. So the sampling settings you are seeing here is the final render settings which I've used for my final render. So I'm just keeping it as it is here. Since I don't have any transmission here, I'm putting the transmission value to 0. I've put the ray depth diffuse value to be 2 so that I get enough bounces when I add the subsurface scattering, and a specular value of 1, which is more than enough on this shader. We'll need more specular depths if we have more reflective objects like mirror or chrome metal, that kind of things, which is reflecting back and forth with each other. And since I'm not using any metallic shaders or classes, I'm putting the ray depth diffuse to be 2 and specular to be 1, and I'm using AOVs like diffuse direct indirect to see how shader is coming. So what I'm going to do here now is that I'm going to add the same switch shader into the subsurface scattering. So I have put the subsurface scattering weight to 1, and I'm going to add the switch shader to the subsurface color. So if I come to the diffuse direct, you can see we are seeing some beautiful scattering. Now I'm going to adjust the radius so that it feels like a Lego, not like a wax shader. So I'm going to put the scatter value to be closer to the yellowish, but I would like to add some orange tint into it. And I'm going to decrease the value so that it doesn't scatter much. And this seems like we are in a good spot. So setting up triplers is a bit lengthy process, takes more experienced eye to understand how much scatter is working better or how much scatter is too much and which is the ideal scattering value which we can add there. So all this will need some time and observation. So you will learn to do this by practicing more, and always keep a reference image with you to understand how the scattering is coming. Since already I have an idea how the shader should look, I'm going to set it up without any reference here. I am still not seeing any scatter to be orangish here. So let me just save this render. And I'm going to do another render with a bit more orange. Let me just reduce the triplets a bit so that the render is faster. So when you're test rendering, you want to see more iterations, and it is always better to go with few samples first so that you can make decisions better. I'll also increase the resolution a bit so that I can see that details better. I guess that makes some kind of orange bounces here, but not much. So I'm going to try to see if I increase the radius a bit, how much scatter that it gives me. So that is giving me a bit more softer tone here. You can see that. And I feel it's a bit too much. So I'll probably put it around 0.15. So sometimes I put the triples weight completely to 1, and sometimes I just put it to 0.9 or 0.8 and use the diffuse value as well, so that I'll get some mix and match. But physically, it's not an accurate workflow. When an object is completely subsurface scattering, it won't have any diffuse information. It will be completely a subsurface scattering object. So here I have completely put the weight to 1, and let me just increase the resolution and see if I can get a better render. So I'm getting much cleaner render and much details I can see. And you can see a bit of orange tones here and there. And when you put a radius color, the trick is it will be more visible in the shadow areas. So look at the shadow areas and see if the scatter is too much or not. If you put the scatter too much, the shadows will be more lighter, and that will give away the impression that the triplus is not properly set, or it is too much subsurface scattered on the object surface. So I think this is now on a good spot to move on with the other settings. So for specularity, I'm going to make it maybe, let's say 0.3. It's just purely your creative call. You want to make it more glossy or a bit rough so that it's more natural. So since it's so miniature, it will have more glossier surface, and I would prefer to have it more glossier surface so that it catches some speculars and creates some dimension or interest on it other than the textures. So I'll put the value back to what it was, 0.2, and let's put the test resolution back to 100%, and let's wait and see a render. So this is our final render. So it took me 38 minutes approximately to get a complete render, and you can see we have lots of variations. We cannot be 100% sure that all the 20 textures are completely visible here, but we are getting a lot of variations. And just like I showed you, you can try to change the gain, min and max value and change the seed to get more variations. And in one of the values, you will get a much better variation, which is satisfying for me. And here some of them you can see like penetrating each other. Make sure that you are resolving when you are caching the simulation. And even in my final render, there was a few of them which was penetrating, and I just decided to avoid all of that because I was going for the overall looks with the lighting and texture variations and shading and all. So for me, at that point, that was some minor issues which was negligible, because the intent of me creating that particular render was to test this AI switch shader to create all these variations in a single instance of geometry. So this is all we are going to talk about in this video. I hope you all have liked it. In the next video, we'll be talking about how I did the final lighting, and maybe I'll tell you a bit about the sampling. But in here as well, I'm not not going in depth into the sampling and rate up because I am planning to get a in-depth video to get an idea about how sampling and rate depth works. So I would prefer that you learn it in a separate video so that you will get a clear understanding of what it is and how to manage it. And if I am adding this in a video which was intended for showing another thing, I'm not getting enough time to explain all the things, and that is like a really quick explanation which is not enough for you to understand these things. I have to explain to you about the noise, what is a noise, how it is generated and why it is generated, and how to resolve this, what is sampling, what are the methods of sampling, and there are a lot of topics which needs to be covered, and that's why I'm keeping it for another session, and I will do it pretty soon. So if you want to get a basic understanding of sampling in the next lighting tutorial, just let me know in the comments and I'll plan it accordingly. So I hope you liked this video and you've learned something from it. And if you have any questions regarding this tutorial, just let me know in the comments and I'll try to answer it. And if you think that the contents I make are valuable to you and you've learned something, please help me grow my channel by sharing and liking this content and also subscribing to my channel, and please share it with your friends who are also interested in lighting, and I'll see you with the third part of this tutorial soon. Till then, this is Swats.